right, students. So this week we are going to simplify radicals. It's an introduction, so like the beginning of it. So let's see how that looks. So a radical, remember a radical? This is the symbol of a radical. We use it for square roots, cube roots, all kinds of roots, right? So instead of using exponents, so it's like undoing exponents, or radicals undo exponents. So let's look at what I'm talking about. First, we need to find numbers. The best, look, if we take this and we use a calculator, we take the square root of that number, it would be some crazy decimal. So that's 48, the square root of 48 is 6.928, and all those numbers. Now, a best way to put it, some people need to be very, very exact. So instead, sometimes you leave it with the radical, basically the answer, because if you take the square root of the cube root of any root of a number, it will be some crazy number like this. So sometimes we need something more exact. So this is when this comes from. So let's simplify this in a better, in a more exact way. So this number 48, you can see that 48, if you use your multiplication chart, you can see that 48 divides by 16. And 16 is a square root. So we can take the square root of that. So something like 3 times 16, right? Now this number is a square root. This number is a perfect square. So if you take the square root of that, it's 4 times 4, right? 4 times 4 is 16. So then we can simplify this number by just leaving this 3 inside and taking the square root of this one and putting it outside. So whatever you can take the square root inside the square root, you can take the square root of any number, you should simplify it into that number and then setting it outside. So if you put this number in the calculator as it is, 4 times the square root of 3, you will get the same number, the same decimal that you got when you did the square root. Okay, but it's just a nicer way to say this is the exact simplification of this without having to write all those decimals. Okay, let's look at this. So in the multiplication chart, you can check. You can divide, we know that 75 divides into 25. So that we know that 25 is a perfect square. So 75 divided by 25. So you basically are looking for perfect squares to get that out of that square root and simplify. So again, we know that this doesn't divide. This does, but you can try it first. So 75, the square root of 75 is 8.66, and then it just keeps going. So we gotta fix this one and put it nicely like this. All right. So we know that 75 is 3 times 25. And then this one, we know that the square root of 25 is 5. So 5 times 5, right? So let's look at that. So we can take the square root of this one, and that would be 5. We'll put it outside, and times the square root of 3. Okay? So you are looking for factors of these numbers. Now this one, we know that if you take the square root of 12, it's a crazy number also. It's 3 point some. But what two numbers multiply to 12 that one of them is a square root? Well, 3 times 4, right? So 3 times 4. And this one you can take off, the square root of 4 is 2. So that is, take it off, and then 2 times the square root of 3 will give you that number. All right, let's simplify this one. Oh, guess what? This one is a perfect square. So this is just the square root of 16. Some of them, remember, you can just find it, okay? So try your calculator. This one is the same case. So use your multiplication chart or just use your calculator. That's 6. Square root of 64, that's 8. 8 times 8, right? All right. What about this one? Well, let's see. 125, the square root of, it's 11 point something. So let's look at 5. Divided by 5, that's 25. There we go. So that is 5 times 25. And then you can take the square root of this one, and then that's 5 times the square root of 5. So you take it outside of the radical. Okay. What about this one? Well, we know that we can't take that one, but we know that two numbers multiplied to 20, that one of them is a perfect square. It's 4 times 5, which is this one. Take out a 2, 2 times 2, right? And then you leave the 5 inside. Because this one, you can't take the square root of that. Okay? All right, let's keep going with this. 18. Well, we look at all the factors. So we have 2 times 9. Oh, there we go. I found it. Because 3 times 3 is 9. So I can just take the square root of 9, and I will get, it's like saying the square root of 2 times the square root of 9. I can take this one, right? So I would put it on the front. So that's 3 times the square root of 2, because you can't take the square root of 2. Okay, if you do, it's a big decimal. So we just leave it like that. All right, let's do this one. We have 2 times 16. And then 16 is a perfect square. We take the 4 out, and we leave the 2 inside. All right, and 50, let's see. We have 2 times 25. Oh, there we go. Could have gone farther, but we leave the 2 out, and we take the 5, the square root of 25. Okay, so you're playing with perfect squares here, right? You're looking for that. This one, we know that 3 times 9 is 27. And we can take the square root of 9 because that's a perfect square. The square root of 9 is 3 times the square root of 3. We leave this one. Okay? All right, students, I hope this helps.